All right, we're going to talk about solving rational equations. So when we're solving rational equations, what we want to start by doing is simplifying each side. So we want to get it into being one fraction equals a fraction, kind of that idea of proportions. And we're still going to have domain restrictions, but so here, what I want to do is I want to find a common denominator throughout my entire problem. So I'm going to factor everything. So here I have x over x minus 3 plus x over x plus 3 equals 2 over x plus 3, x minus 3. So now I'm going to look at that common denominator like what we did when we added and subtracted rational equations. So here, I'm going to find my common denominator, which is going to be x plus 3, x minus 3. So this is missing the x plus 3. So I have x times x plus 3 plus this is missing the x minus 3. So I'm going to multiply by x minus 3. X plus 3 over x minus 3. And this side is missing nothing. So I'm just going to rewrite it. Okay. Now, I'm going to simplify this a little bit. Right here, I can talk about my domain restrictions. So I got to find those values that are going to make this be 0 in the denominator. So that's plus or minus 3. Okay. So now once I have a common denominator, the nice thing is I can kind of ignore it. I can just work in the top. So I'm going to work on the top, or the numerator here, and I'm going to solve the numerator. Because what would I do is I'd actually multiply everything by x plus 3, x minus 3. So all those would cancel out anyways. I just need to make sure I have my domain restrictions. So I'm going to go here. This gives me x squared plus 3x plus x squared minus 3x equals 2. Right. So I'm going to bring that up here. So I'm going to just simplify it. 2x squared. My 3x's cancel out equals 2. And now I'm going to solve for x. So I'm going to divide by 2, x squared equals 1. The way I get rid of a square is I square root it. That gives me x equals square root of 1 is plus or minus 1. There's my answers. So I have positive 1, I have negative 1. Those are going to be my solutions. Okay. So we'll do one more problem. We'll do one more example, and then that will be solving rational equations. So I'm going to start by factoring everything so I can find a common denominator. So here it looks like the only thing I have to factor is my x squared plus 3x. So I have x minus 1. This gives me x plus 2, x plus 1, plus 2x over x plus 2 equals x minus 1 over x plus 1. So my common denominator is going to be x plus 2 times x plus 1, because there's the identical pieces there. So the first part, I'm not missing anything. So I'm just going to rewrite it. Now this is missing the x plus 1. So I'm going to multiply 2x by x plus 1. This side I'm going to multiply by x plus 2. Okay. Now I should talk about my domain restrictions. X cannot equal, well, what are the two values that are going to make this 0? -2 and -1. So those are my domain restrictions. I want to make sure if I end up with an answer that is one of these two, it's not a real answer, it's an extraneous solution. So now I'm going to just look at my top, and I'm going to go ahead and start distributing this also. So I have x minus 1 plus, I'm going to distribute my 2x. 2x squared plus 2x equals, and I'm going to FOIL this out, x squared plus x minus 2. And what I'm going to do is I'm going to get everything on one side. So I'm going to bring my x squared plus x minus 2, and I'm going to bring it over to the other side. So I'm going to just simplify this side first, though. Okay, I'm going to subtract off my x squared, my x. I'm going to add my 2, so minus x squared minus x plus 2. And this gives me x squared plus 2x plus 1 equals 0. And what I'm going to do now is I'm going to factor this. So I end up x squared plus 2x plus 1 equals 0. I'm going to factor this into x plus 1 squared equals 0. What makes this 0? Negative 1. But our problem is that here we had negative 1 cannot be a solution. So since this cannot work, we have no solution. I always got to check back to my domain restrictions to make sure it's not one of them. That's solving rational expressions.